remains? Angular velocity of every particle is remains what? Same, because they are revolving around the what? Same pivoted point. So that angular velocity remains constant. So I will replace everything. So everywhere, what is that V? V is equals to R1 into omega. Next, V1 it is. V2 is equals to R2 into omega. V3 is equals to R3 into omega. Like same way, Vn is equals to what, everybody? Vn is equals to what, everybody? Rn into omega. Are you clear, everybody? So that is what it is. So I will replace. This is for total. Now I will write it for this one. So I will replace it half into m1 into. What do you mean by v1 square? V1 square. V1 means R1 omega. So V1 square means what will happen? R1 omega whole square, which is equals to R1 square omega square. Clear? Shall you understand, Mr. Kadir? So R1 into R1 square omega square plus half into M2 into what will happen? R2 square omega square. So on. Last will get half into Mn into Rn square omega square. So in this all something is constant. What is remains constant? Everybody? Yes, please. Omega is remains constant. So half into omega square constant, I will take it. Remaining what is there? M1 R1 square, M2 R2 square plus, you want you can write M3 R3 square plus so on, Mn Rn square. So we all knows that. We are very familiar with this one. So M1 R1 square plus M2 R2 square plus M3 R3 square plus so on, which is equals to something. What is that? Anybody? Naren? Sai Karthik, Rishi, what is that, everybody? Which is equals to what? Yes, please. I. So that is only moment of inertia. So moment of inertia is equals to, so that is what? I omega square. So that is the kinetic energy of a rotational body. So that is only the formula which I have taught you beginning. Am I right or wrong? Everybody clear? Understand?
Yes, sir.
So this is the proof for kinetic energy of a rotational body, rotating body. Any doubt? Anybody can ask. Answer, Mr. Rohit, Rishi, Ryan.
Yes, sir.
Proceed. So next, this is what work done by what? Sorry, kinetic energy of a rotating body. Now we are making work done by the torque in a rotating body. That is what we have to find it. So what is the work done formula? Basically, integral something. We are having a formula. Yes, Mr. Rudreswa? You have already studied second chapter, I think. Second chapter, third chapter. Yeah. Work done by a torque. We want to find it now. So torque. Okay. So work done by a torque. That is what is our target. So now we all people know, so work done in a horizontal water. What is that? Integral part of what is the formula? F into ds. So that is the formula for work done. Now we wanted work done by torque. So that what will happen? Here F in angular motion. What is that? Rotational motion. F become what? Torque. Here ds. Here will become what? Everybody? D. So this is only the formula for work done by the torque. Brothers, understand? Work done by the torque is equals to, you want you can write it. Work done by the torque is equals to integral tau theta d theta. So that is only the formula. So now we want to find it. We want to make the proof. So let's start the proof now. If you are okay, then I'll proceed it. Okay, so everybody ready? Understand, all of you? So that is only the last of today's class. So let me take some random body, your choice, random body. So which has been pivoted at this point. This is the pivoted point. Okay. Now I have chosen some particle away from it. So who is having a force F? Okay. So it is actually rotating. So imagine the distance between them. I'll take it as a what? Everybody? R. Now imagine just it has been made some rotation. Torque means what? Angular displacement. Torque means angular displacement. It has been there. So just I'm imagining it has been moved to certain distance, just very small distance. Angular, it is what it is. So it is making a theta. Okay, how much theta? Very small theta. So small theta means what will represent? Everybody. D theta. Clear? So this particular one, I am going to make it a big one. So just imagine it has been made it a very small d theta. And this is the one actually. So this distance only we used to call something. What is the distance we used to call it as? Everybody? ds. Clear? And there are force which is exerting F. So resultant force. So now here the force is acting resultant force. So then force will split into two different directions. One is x-axis, another one is what axis? Everybody? Y-axis. So it has been made an angular velocity. So angular acceleration alpha. Now tell me here what will happen? Everybody, perpendicular force. This will become what? F cos alpha. F sin alpha. Sorry. F sin alpha. Angular acceleration. F sin alpha. So now this F cos alpha only something. Anybody can tell me for this particle, F cos alpha is something. Anyone? What is that? Which is equals to F perpendicular. Understand, brothers? Rudreswar? Clear? So, and we all know that we have already studied d theta is equals to what is the formula? Anybody can tell me? You already studied it. Remember and tell me. D theta is equals to what is the formula? D theta is equals to what is the formula? ds by this is r. ds by what? R. Distance by that is what? ds by r. So we all knows that work done is equals to what is the formula? Force into displacement into cos theta. Now it is very small particle. So dw is equals to what is the force? Applied force is F. Okay, F into S into cos theta. So now we all knows that F and ds means what? ds and cos theta means what? Cos alpha. So now all of you observe, can I write this one as a F cos alpha into ds? I can write it or not? Everybody? I can write it.
sir.
So now F cos theta. Now from this we can see ds is equals to d theta into r. So I'll replace it. ds means d theta into r and F cos theta is equals to something. Verified everybody. F cos theta is equals to what actually it is? F cos theta is equals to what? Everybody. It is the perpendicular force. Understand? Yes. It is F perpendicular. So I'll replace F cos theta. I can replace with what? Everybody. F perpendicular. F perpendicular. So F perpendicular R into d theta. So F perpendicular into R, which is equals to something, which I already studied. So tau is equals to what? F perpendicular into R. Am I right or wrong? Everybody?
Yes, sir.
That's all. So work done is equals to tau into tau d theta. So that is how it has been got it. Clear? So or else you can say, so tau is equals to, we all knows that R into F. So we all knows that R into F means what? F perpendicular. Clear everybody? So F perpendicular. So you can apply integral work done is equals to both the sides integration. So integration tau d theta. Clear everybody? So if I apply integration of dw, what is that everybody? Integration of dw is w, dw equals integration of d theta. So sorry, integration of d theta, this is w. So yeah.
That one W.
Yes. So integration of dw is w. So w is equals to what is the formula? Everybody? Work done by the torque is equals to integral tau d theta. So that is only the formula. So t d theta, we have to do this one. So this is the work done by torque and as well as kinetic energy of a rotational body. If you have solved these two, then we will solve the numericals related to this. You can practice and then directly we can move to the next concept. So these concepts are very, very important. So even for school exams also, for derivations, they will ask you. So work done by torque. Do you understand, brothers? Anything doubt here? So very simple it is. So now why I am taking the force? Because the body is revolving in this along about this pivoted point, the rigid bodies. So rigid bodies always what is happening, everybody? So rigid bodies, angular momentum or angular velocity always remains what? Remains constant. So that is what you have to remember and you have to proceed, make it. So along the pivoted point, if you have been taken, so it will be producing torque, work done by the torque is equals to, so what will happen? Integral part of tau d theta. So that is what is the derivation. So it's very simple derivation. So you can take it. So just you can proceed. So perpendicular force is F cos alpha. F cos alpha is equals to F perpendicular. And we all knows that this d theta, this is not theta, it is a d theta. So d theta is equals to ds by r. So from that ds is equals to dr theta, d theta into r if you have been solved. So then work done is equals to, we all knows that fs cos theta. So fs cos theta is replaced with the things, everything. So force means force, F and S means ds, and cos theta means cos alpha. So F cos alpha is F perpendicular, d theta r, and F perpendicular into r, we all knows that it is tau. So tau d theta. So this is what it is. If the smaller particle, integral dw is equals to, if you apply, so what will happen? F perpendicular into r. So F perpendicular into r is only, we can say what? F perpendicular into r is only, what is that? Tau d theta. Clear, everybody? So that is what you have to remember. Anything doubt, you can ask me. So F perpendicular into r is only tau. So that is what? Tau d theta. So integral part. That's all it is. Any doubt? Clear, everybody? Understanding?
Yes, sir.
Yes, sir.
Yes, sir.
So this is what is about work done by the torque and kinetic energy of a rotational motion. So both proofs you learn, and this hinge forces questions, please kindly practice now. So and then only you can go to the some other thing. So if you have been completed this, then we can wind up till here. We'll continue numericals and everything in the next class. Okay. So get back to work. Anything doubt, you please kindly ask me. I'll explain you. And otherwise, you can leave from the meeting and you can start practicing. Okay. Thank you, everybody.